A new era in urban transportation has begun with the advent of eVTOL, electric vertical takeoff and landing air taxis. By combining an electric drivetrain, autonomous or semi-autonomous control, and small vertical lift capabilities, these aircraft are designed to reduce urban congestion and offer effective short-haul transportation in crowded urban settings. Their cabins exhibit a precise balance between aviation-grade engineering and urban transit needs, with a focus on passenger comfort, safety, and speed. Number 1. Cabin configuration and design. Depending on operator preference and design, the typical eVTOL air taxi can accommodate 2 to 6 passengers, with movable seating arrangements that maximize the fuselage's limited capacity. The interior is incredibly modular. Luxury versions feature individual ergonomic seats with armrests and small personal storage, but most designs use side-facing or forward-facing bench-style chairs for convenient boarding and disembarking. The layout of the cabin prioritizes ease of access and rapid turnover. The cabin floor is level with low-step heights to facilitate boarding for people with limited mobility, and large gull-wing doors or sliding entrance panels allow passengers to enter and exit quickly. Visibility is a key component of architecture. Panoramic glass and floor-to-ceiling windows are common and give the impression of space even in small spaces. More operational flexibility in urban air mobility, UAM services, is made possible by the ingenious layout features of air taxis, which have lightweight partitions, flexible floors, and folding seats to accommodate passengers, small cargo, and ride-sharing models. Number 2. Interior materials and finishes. The interior materials of eVTOLs prioritize safety, durability, and lightweight while maintaining a modern look. Composite panels with aerospace-grade polymers and carbon fiber reinforcement make up the cabin walls and structural elements. In order to preserve cleanliness and durability under frequent use, upholstery commonly uses vegan leather with antimicrobial treatments or flame-retardant synthetic textiles. Soft-touch panels on the sides reduce the risk of damage during stormy flight or abrupt vertical movement, and the flooring is composed of lightweight, non-slip materials that can withstand rapid boarding and luggage movement. In order to facilitate maintenance, cabin finishes usually feature clean, simple lines with matte or gloss surfaces. Additionally, ambient LED lighting that is colorful enhances passenger comfort, while indicating operational stages such as emergency situations, departure, and landing. Number 3. In-cabin entertainment and connectivity. Even though eVTOL air taxis were designed primarily for short urban trips, they are increasingly offering internet connectivity options. Wi-Fi or a 5G connection for smartphone access are common features of passenger experience systems. Seatbacks or overhead panels are equipped with interactive flight information displays, voice-activated cabin assistance for system status, emergency instructions, and route updates entertainment content that can be streamed on personal devices. Since short-haul flights, typically less than 20 minutes, put comfort and speed ahead of prolonged media consumption, entertainment is minimal and optional. Number 4. Noise reduction and cabin environment. A key element of eVTOL design, especially for urban adoption, is noise control. Compared to conventional combustion engines, electric propulsion technologies produce significantly less engine noise. A quieter travel experience is facilitated by active noise-canceling materials in the cabin, rotor positioning, and blade design. Cabin airflow is controlled by electric air circulation systems, which also maintain comfortable humidity and temperature levels. Vibration transfer to the cabin is reduced by advanced insulation around electric motors and rotors. Even during vertical lift and hover, there is a calm atmosphere thanks to the double-glazed and laminated windows that cut down on outside noise. Number 5. Cockpit and avionics. eVTOLs typically employ either pilot-assisted systems or fully autonomous flight control. The cockpit of piloted versions is small and streamlined, featuring fly-by-wire controls, digital displays, and intuitive touch interfaces. Algorithms for navigation and guidance in semi-autonomous systems are tailored for urban environments. LiDAR, radar, and optical cameras are examples of collision avoidance sensors. Route planning incorporates real-time traffic and weather monitoring. Hover stabilization, automatic vertical takeoff, and landing AI-powered decision-making and sophisticated flight computers are necessary for fully autonomous models. These systems allow ground-based operators to observe or take action remotely while controlling ascent, descent, hover stability, and obstacle avoidance. Number 6. Advanced safety features. Because safety is so important when flying in cities, eVTOL air taxis have many redundancies, multiple independent propulsion units for forward flight and vertical lift, as well as redundant flight control and power electronics, pilot and cabin emergency parachute systems, diagnosis of preventive maintenance and real-time structural health monitoring, sophisticated automatic rerouting and collision avoidance features, systems for detecting and putting out fires in the cabin and battery packs. Redundancy and distributed electric propulsion reduce the chance of catastrophic failure, boosting passenger confidence and regulatory compliance. Number 7. Performance and efficiency. eVTOLs are designed for short trips in cities, not for long-distance travel. One of the main features is that it can take off and land vertically in tight spaces without runways. Depending on the design, cruise speeds can be anywhere from 100 to 250 kilometers per hour. The battery usually lasts between 15 and 45 minutes of flight time, and it doesn't take long to charge or change the battery. Electric propulsion that uses less energy, cutting down on emissions and operating costs. Agile maneuverability for getting through tight city streets. Energy management systems keep an eye on how well batteries are working and make sure that power is evenly distributed between lift rotors and forward propulsion units. Number 8. Exterior and aerodynamics. To maximize energy efficiency, eVTOL air taxis frequently feature small, low-drag aerodynamic fuselages. Typical traits consist of: for dependable vertical lift and effective forward flight, use multi-rotor or tilt-rotor configurations. Rotors that are folded or covered can reduce noise and improve safety around city infrastructure. Composite fuselage panels that are lightweight and aerodynamic LED navigation lights, and high-visibility paint jobs for urban airspace safety. In densely populated areas, aerodynamic efficiency is especially important for increasing range while reducing noise. Number 9. Baggage space. Despite being primarily designed for passengers, eVTOLs have small integrated storage spaces. Briefcases, small bags, and light personal belongings can be kept in underseat compartments, rear fuselage lockers, or overhead cubbies. The aircraft's small size and weight restrictions, which guarantee that passenger weight stays within operating limits, limit cargo capacity. Number 10. Cost of ownership. eVTOLs may be less expensive to operate than conventional helicopters due to their electric propulsion and less complicated mechanical systems. Benefits consist of fuel and maintenance costs are reduced with electric motors. Compared to rotorcraft, the mechanical complexity is negligible. Reduced downtime and quicker replacement are made possible by modular batteries. Possibility of high-frequency, asset-efficient urban services. Modern materials and avionics may result in high initial procurement costs, but these costs may eventually be offset by operational savings and environmental incentives. Number 11. Pros and cons. Pros: quiet, efficient, and low-emission urban transportation. Vertical takeoff and landing removes the need for runways. Advanced safety and autonomous features reduce the pilot burden and operational risk. Interiors are modular and versatile, adapting to passenger and cargo demands. Lower operational expenses than conventional helicopters. Cons: limited range and durability owing to battery capacity. Small cabin size limits passenger and luggage volume. Dependence on modern infrastructure for charging and vertical ports. Regulatory barriers to urban airspace integration. Early-stage technology may need extensive maintenance management and software upgrades. The eVTOL air taxi is a carefully designed blend of urban practicality, safety, and passenger comfort, providing a look into the future of intercity and intracity aviation travel. If this video helped you, please like, subscribe, and share it.